Quiet please, let's get started. Squares of binomials. What we're going to do today is another important pattern. We did the difference of perfect squares. That was a pattern. This is another pattern that we will be using not just in this chapter, but in many of the later chapters in the book. Now, here's a binomial. If this section is titled Squares of Binomials, what do you think that means I'm going to do to the binomial? I'm going to square it. Now, think about what that means. I'm going to write this underneath. This is not part of the pattern, but just a reminder. What this means is whatever is in the binomial repeated times itself. Notice this is different than the pattern we did on Friday. On Friday, we had the exact same thing in the parentheses, but one plus and one minus. Today, the pattern is exactly the same thing in both parentheses. Now, if you see something like this, you could write it as two of them side by side, and you could FOIL it. But there is a pattern, and you do need to become familiar with the pattern. So, here's the pattern. The first term would be a squared. The middle term is 2 times a times b, and the last term is b squared. Now let's think about comparing this again to the pattern from Friday. On Friday, this middle stuff all dropped out, and we had a minus, a squared minus b squared. We've got something similar. We're going to square the a. We're going to square the b. But because it's the same, let me just show you if we were to FOIL this, and you don't have to write this down unless you want to, you can just look. If I did first, a times a squared. When I do my outer, I get a times b. When I do my inner, b times a or a times b. Look at what we've got, a times b, and there are two of them. The pattern is showing that because these are exactly the same, my outer and my inner give the same answer, so 2 of those ABs. And then finally, if I do the L and FOIL last, b times b, there's my b squared. So you can still get this from FOIL. Now, there's the first pattern. That's if it's a plus. One pattern with a plus. The second pattern is the exact same thing, but it's a minus. So this would be a minus b times a minus b. Again, the same sign. Not Friday, difference of two perfect squares with different signs, the same sign. Now, everything is going to work out if we were to write it side by side and to FOIL it. Everything is exactly the same except for this one minus sign right here. It's the only difference. If this is a minus, this is a minus. And notice the last one is still plus b squared. Here's why. Again, if you want to just write this down, if you want to just watch, you can. I'll just show you what would happen if we FOILed it. A minus b squared means a minus b times itself. When we FOIL, a times a, there's my a squared. Because it's a minus, when I do my outer, a times negative b, negative ab. Inner, negative b times a, well, let's rewrite it alphabetically. They're both negatives, but there's still two of them. So that's where we get the middle piece. Now last, negative times negative, oh, that's a positive. So for the last, the negative times negative always makes a positive. So the only change in the formula is this first minus. Let's try a couple. I'll show you how it works with actual binomials, not just the a and the b. So let's do the first one. Let's do x plus 3 squared. Now we could write it side by side and FOIL it, but I want to practice using the pattern. Now, according to the pattern, let's identify it uses a and b. So I'm writing that underneath just so we can see. If the pattern says a squared plus 2ab plus b squared, again, in pencil here, I'm just recopying the pattern. Let's see if we can do this using this shortcut pattern instead of FOILing it. So the first one should be a squared. Now I wrote this just so we can compare. What's my a in this orange example? Oh, that's x. So I square it. This says a squared. Here's my a. What's x squared? X squared. Now, for myself, I like to do the easy parts first. Can anybody relate? Do the easy part first? Yeah. Let's do the easy part first. B. There's my B is 3. The last one says B squared. If my B is 3, what's 3 squared? 9. Now, in the middle, not that it's that much harder, but 2 times A times B, 2 times X times 3. Well, that's not how I would write it. How would I write 2 times X times 3 in a more simplified way? Vincent? 6X. 2 times 3 is 6, times X, 6X. Now, you don't have to do that middle part last like I do. I like to do the easy A squared, B squared, and then fill in the middle part. But you can do it however you like. Does that make sense so far? Okay, let's try another one. Let's make it one step different. Let's add a number with that first variable. 7u minus 4 squared. Now again, pay attention, we've got a minus here. For these first couple problems, I'm just going to write the pattern underneath. You can do that if you like, or you can just look at the pattern at the top. Remember, we have a minus. So this is just what I'm going to look at if I want to use the pattern. I figure out what's my A and what's my B. Again, I like to do the easy parts first. So it says, okay, the pattern says A squared. What's my A? 7u. Okay, how do I square, what do I get if I square 7u? Roland.
49 squared.
Perfect. Don't forget the number, right? 7 times 7 and u times u. Okay, let's go to the easy part. Let's do B squared. I look at my B. What am I going to get if I square my B? Daniel?
16.
Good. And again, it's always a positive because it would be -4 times -4 if we were foiling it. Now, the pattern says I should have a minus in the middle. That's the only thing that changes. 2 times A times B. Now again, for some of these, write it down if you need to. It's 2, always 2, times my A times my B. If you can do that in your head without making a mistake, great. If not, just write it down. I can reorder this using the commutative property. 2 times 7 is 14. 14 times 4 is 56 times u, 56u. So if you go carefully, it shouldn't matter if there's variables and numbers on all those terms. You should still be able to follow the pattern. Now, here's the real test if you understand the pattern. Let's go backwards. Decide if the trinomial is a perfect square. So basically, what you're going to do here, I'll show you 2 examples of this, is you'll be given something that looks like the trinomial, the end of the pattern. And you have to decide, could this have come from the square of a binomial? First one, 4x squared minus 20x plus 25. I notice that there's a minus, which means that if this is a perfect square, right, remember, a squared minus 2ab plus b squared, I'm just flipping it around this time and putting the trinomial first and the binomial second, it would look like this. A minus b squared says I'm going to have a squared minus 2ab plus b squared. So I just flip-flopped that around. If I have this, does it match what it should be if it came from a binomial like this? Let's check it out. Let's start with the easy part. 25 is b squared. So what's my b? What did I square to get 25? Diego? 5. Okay. All right, b squared. Okay, let's go back to 4x squared, the other part. If this is a squared, what's plane A? If this is it having been squared, what did we start with, Jaylene?
2x.
Good, 2x. 2 times 2 gave me the 4. X times x gave me the x squared. We have one step to check. This is the most important step. Does this equal what we would get if we did 2 times a times b? Now I've got my a and my b. Let's check it. 2 times a times b. 2 times 2 is 4, times 5 is 20. This equals 20x. Oh, this has 20x. Guess what? It is a perfect square of the binomial 2x minus 5 times itself. It worked. So what we're doing is we're checking each part we're figuring out what is it the square of, and if it fits the pattern, if it works, then this is our answer. Is this a perfect square? Yes, the perfect square of this. Let me show you what it might look like if it doesn't work. Did this make sense first before I show you when it doesn't? Going backwards? Okay, let's try one more. Same topic, decide if it's a perfect square. 64u squared plus 72uv plus 81v squared. Oh my goodness, this one has so much more. Let's see if we can figure it out. Would it fit this pattern? Now again, I'm writing the pattern underneath each time. You don't have to do that, but if it helps you, it doesn't take long. Because this is a plus, it would all be pluses all the way through. Okay, so we look at it and we're going to decide first, let's work on our A's and our B's, and then we'll see if the middle part matches 2 times A times B. First we got to figure out what A and B are. All right, what would I have squared to get 64u squared? What times itself? Jim? 8 and u. 8u times 8u, 64u squared. What was my b if this is b squared? What did I square to get this? Carissa?
9u.
Good. 9 times 9 makes 81, and v times v makes v squared. Now let's check. 2 for the middle times my a times my b, right? We had to first figure out what's a and b before we can check the middle term. 2 times, actually I'm going to go the other way because I can't do I don't want to do 16 times 9 in my head. 9 times 8 is 72, times 2 is 144 uv. That's what the middle term should be. Uh-oh. It's not. It doesn't match. Not a perfect square. This trinomial that they gave us does not come from the square of a binomial. Because if it did, the middle term would be 144, not 72. So first you figure out what would the A and what would the B values be, and then test it out to see if 2 times A times B matches the middle. If it does, like the first example, then you just give me the answer of the binomial that is squared. If it doesn't work, you say, nope, not a perfect square. It did not come from squaring a binomial. That's it. That's the pattern. It is an important pattern. We'll be using it a lot, so practice with the pattern.